Hello friends, welcome to Susan and John MathTube. Today we are going to learn about Fourier series. And just like the name suggests, we are going to convert functions into a series form. So let's start with a function, say f of x. Of course, f of x has some conditions, but at this moment, let's not try to complicate things. So let's imagine we have a function f of x which is defined in an interval of length 2L. Okay, now look at this. Our aim is very simple. Our aim is to convert f of x in terms of sine and cosine. So, what's the objective of Fourier series? It's really simple. Our aim is to convert f of x in terms of sine and cosine. And like the name suggests, we are going to write it in series format. We are going to write this function as a convergent series. I hope you remember what is convergence, and I hope you remember what's a series. Okay, now look at this. Suppose we have a sequence, let's say u1, u2, u3, etc. And we consider the series by taking its sum to infinity. That means we are going to find out what will be u1 plus u2 plus u3 plus etc 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 up to infinity. And in your previous semester you might have learned that sometimes the sum will be a finite number, and if it is a finite number, you say the series will converge. And in case you get infinity, you say that the series is divergent. Now we'll come to the point. So our aim is to write the given function in terms of sine and cosine series in such a way that it will converge to f of x. Okay, now let's have the formal definition. So let's say we have a function f of x, and there are a few conditions like bounded, piecewise continuous, etc. etc. But for the time being, you have a function which is defined in an interval of length 2L. Now what we do is we write f of x in terms of sine and cos, and the final format will be a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Okay, now this series is called a Fourier series. So look at the amazing part. This side, the left side can be maybe x square, and you know that x square represents a parabola which is symmetric about the y-axis, and the right side is in terms of sine and cosines, and you know the graph of sine x, sine 2x, etc. All the graphs will be in wave format. So the amazing part is we are going to convert a picture which looks like this in terms of sine and cosine. Not one term, not two terms, but infinite number of sine and cosine. And the more terms you write, it will keep on converging to f of x. Okay, now these values, this a0, an and bn, these are called the Fourier coefficients. And in the math exam, you have only one job. You have to find a0, an, bn. Substitute, that's it. They will happily give you the mark. Okay, so let's make it clear for the last time. So you have a function f of x which is defined in an interval of length 2L. And what we do is we convert, or we are trying to convert, this function into a convergent series, which is written in terms of sine and cos. And your aim will be to find a0, an and bn. Now look at this. a0 is given by 1 by L integral. In my opinion, you don't have to worry about the limits right now. Whatever they give, you put it over here. I'll repeat, whatever the interval, you put the lower limit and the upper limit here. And f of x dx. Take a piece of paper and a pen and note 1 and then this a0. Now comes an. An is given by 1 by L. As before, I'm not going to write the limit. You can just copy the endpoints of the given interval, and it will be f of x into cos n pi x by L dx. And bn is given by 1 by L integral f of x into sine n pi x by L dx. So I want you to note these things. So we have a function defined in the interval of length 2L, and our objective is to convert this function and put it in terms of sine and cos. And the simplified format looks like this: a0 by 2 plus sigma an cos n pi x by L plus bn sine n pi x by L. And a0, an, bn, they are called the Fourier coefficients. They are given by 1 by L, and don't get worried about the limit. Limit is the endpoints of the interval, the lower one and the upper one. Okay, now let's try one question and make it more clear. So, are you ready with paper and pen? So, please note this question. Obtain the Fourier series for the function f of x is equal to x square, which is defined in the interval 0 less than x less than 2 pi. So look at this. The function is a parabola, or rather let's say part of the parabola, which is defined from 0 to 2 pi. Pi is approximately 3.14, so 2 pi will be 6.28. So our graph will be something like this. We have 1, 2, 3, 4, 5, 6, and at 0 it's not defined. Anyway, at 0 it will be 0 square 0, and at 1 the height will be 1, and at 2 the height will be 4 units, and it keeps on growing. Okay, and our claim is we can change this parabola and put it in terms of sine and cosines. Oh, that's really amazing. Okay, so let's give it a try. So, given any question, the first thing to do is note the length. And remember, in the formula, length is 2L. So I'm going to write 2L is equal to, what's the upper limit? 2 pi. And what's the lower limit? 0. And 2 pi minus 0 will give me 2 pi. So 2L is equal to 2 pi, and that gives me L equal to pi. So I'll put it in a box. Okay. The second thing to do is you write, let the given series be represented as a0 by 2 plus sigma an cos n pi x by L plus bn sin n pi x by L. Of course, n will be from 1 to infinity. Okay, now what we do is we'll substitute. What's the value of f of x? Yeah, f of x is x square. So I'm going to write x square is equal to a naught by 2 plus sigma n equal to 1 to infinity an. Now look at this, we know the value of L is pi, and if I plug in pi here, this pi and pi will get cancelled, and I'm going to get cos nx plus bn sin nx, and let's call it equation number 1. Okay, so I hope you're okay up to this, because I'm going to erase these things. Okay, so the first thing, we have a function f of x equal to x square, and then what we do, we write the length of the interval. The length of the interval will be 2 into L, and we found L. Then we write the most general format of Fourier series and substitute. On the left side, you substitute the value of the function, and on the right side, you put the value of L and simplify a little bit, call it equation number 1. Okay, now let's proceed. Now what we do is, we are going to find the Fourier coefficients. So the first thing to find, a naught. So I hope you wrote the formula for a naught. So can you just check it and tell me? Okay, that will be 1 by L integral given limits f of x dx, and that means I'm going to get a naught is equal to 1 by pi integral 0 to 2 pi. That's the lower limit and the upper limit, and our function will be x square dx. Now it's just integration, and I'm sure that you know the formula. Integral x power n dx is x to the power n plus 1, the whole divided by n plus 1 plus c. Okay, so let's substitute. So we get x cubed by 3 within the limits 0 to 2 pi, and that's going to give me 1 by pi, and I'm going to take that 1 by 3 x cube within the limits 0 to 2 pi. That is 1 by 3 pi. Okay, now tell me what happens when you plug in this value. Okay, 2 cube pi cube, that will be 8 pi cube minus 0, and on simplification I'm going to get 8 by 3 pi square. So let's note it here. That's one very important value. A naught is equal to 8 by 3 pi square. So please put it in a box. So let's go through it once more. So what's our aim? Our aim is to convert the given function in terms of sine and cosines. And we have a standard formula, and we ended up in equation number 1. I hope you remember equation number 1. Now our objective is to find a naught. Okay, already done. And now we are going to find an, and finally bn, and that's it. That's the end of the story. So we have a naught. Now I hope you have noted all these things. Let's go to the next page. Okay, now let's start with a n. So an is given by 1 by L integral f of x into cos n pi x the whole divided by L dx. Okay, and I told you not to worry about the limits. That will be the lower limit and the upper limit of the interval. So we get an is equal to 1 by pi integral 0 to 2 pi, and our f of x is x square and cos n pi, and this pi and pi will get cancelled, nx and dx. Okay, now look at this. You can apply integration by parts, but the best method available is Bernoulli's rule. Look at this. You'll be facing tough integration in Fourier series, and whenever we have an integral in the form integral of the first function, a polynomial, and then the second function being sine or cosine or exponential, the best available method is Bernoulli's rule. And Bernoulli's rule goes like this. You can note down the rule. Suppose you have u into v, and remember the method is best provided the first one is a polynomial and second one might be one of sine or cos or exponential functions. And the rule is very simple. First function and integral of the second. I'm going to denote integral by bar. Minus, you differentiate the first, which I'll represent by dash, and integrate the second function again. And you keep on continuing this process unless and until the first term, that is u, will disappear. And the sign will be plus, minus, etc. Let's give it a try. Suppose you have x square and e to the power 3x dx. Okay, so let's try the rule. So first function and the integral of the second will be e to the power 3x the whole divided by 3 minus the derivative of the first function is 2x, and then what you do is you integrate this again. So you get e to the power 3x the whole divided by 9, and again plus. Now you differentiate the first function again, and then you integrate the second term. That will be e to the power 3x the whole divided by 27. Now you can stop here, because if you differentiate this function it will vanish. So let's go back and try to find an with this amazing method called Bernoulli's rule. So I hope you can see a polynomial and a trigonometric function over here. So the answer will be an is equal to 1 by pi, and now inside a big bracket. Okay, so tell me, what's the first function? X square. And then the integral of the second function, I'm going to put it in a bracket, sine nx the whole divided by n. Anyway, it's a definite integral, so we should put limits 0 to 2 pi. Okay, now minus inside another brackets. So look at this, x square will become 2x, and the quantity inside the bracket. So what's the integral of sine nx by n? That will be minus cos nx the whole divided by n square within the limits 0 to 2 pi. And finally put a plus and the last bracket. This 2x will become 2 and the quantity inside the bracket will become minus sine nx the whole divided by n cube, of course within the limits 0 to 2 pi. And that's it. I'm going to stop with this because if you differentiate 2 once more it will vanish. Okay, so I hope you're okay with this step. Anyway, I'll erase the part above this so that I can write. Okay, now look at this. So an is equal to, I'll strongly recommend you not to skip this step. In this step I'm not going to substitute this value for x like upper limit and lower limit. I'm going to clean up. I'm going to simplify these things. So look at this. The limit belongs to x. That means n is a constant. So I'm going to write 1 by n and then x square sine nx within the limits 0 to 2 pi minus, now tell me, minus and minus will be plus, and then the constants are 2 by n square. So just keep the constants outside and inside the bracket we have x cos nx within the limits 0 to 2 pi. And now the last one will be minus 2 by n cube and sine nx within the limits 0 to 2 pi. So I hope you're okay with this step, and I'll strongly recommend, even if you are smart with substituting the limits, don't skip this step, because even one small mistake will make a huge mess. Okay, now look at this. I think you're familiar with the graph of sine and cosine. The graph of cosine starts with 1 at 0 degree and it keeps on moving like this every 90 degrees apart. So what I'm trying to tell you is cos 0 is 1 and cos 90 is 0 and cos 180 is minus 1 and 0, 1, etc. So if you don't know, you can note this somewhere. Cos n pi is equal to minus 1 the whole power n, and sine n pi is equal to 0, and cos 2n pi, look at this, 2n stands for an even number. If you take any integer n and you multiply by 2, that will give you an even number. So this 2n stands for even number, and that will be minus 1 to the whole power 2n according to this formula, and that will give us 1. So it's time to substitute. I'll erase all these things. Okay, so we'll save a lot of time in this step. So tell me, what is going to happen if you substitute 2 pi instead of x? Okay, I can see you're going to get sine 2n pi, which is equal to 0. And when you substitute the lower limit, this part will vanish. Of course, 0 into something will be 0. So the first term disappears. Now you have to be very careful with the second term. When you substitute the upper limit, we will get 2 pi cos 2n pi. I told you just a minute back, cos 2n pi is equal to 1. So now we'll go for the lower limit. Wow, that's easy, because when you substitute, you're going to get 0 into something, and that will be 0, of course. And now the last term, that is 2 by n cube. Now some good news. When you put the upper limit, you're going to get 0. The same thing when you substitute the lower limit, because sine 0 is 0. So the last term will also disappear. So that reduces to 1 by pi, and then 2 by n square, and finally 2 pi. And that's going to give us 4 by n square. So you can note it somewhere. An is equal to 4 by n square. So please put it in a box, and let's go for the last part, and that will be Bn. Now it's your turn. So tell me, what is the formula for Bn? Yeah, great. 1 by L integral, don't get worried about the limit, f of x sine n pi x the whole divided by L dx. Okay, time to substitute. So Bn will be L is pi, and the limits are from 0 to 2 pi. And what was the function? Yeah, our parabola, x square sine, and I told you before, when you put L equal to pi, this pi and pi will get cancelled, and you end up with x square into sine nx dx. Wow, look at this, polynomial and sine. So what should we do? Yeah, Bernoulli's method. So let's try Bernoulli's method. I'll start from this end. So Bn will be 1 by pi, and I'm going to put a big bracket and one small bracket. So tell me, first function and sine will become minus cos nx by n, of course within the limit 0 to 2 pi. Okay, now minus another bracket. Now tell me, what happens to this x square? It will become 2x, and the quantity inside the bracket, once we integrate, will become minus sine nx the whole divided by n square, and within the limits 0 to 2 pi, plus if you differentiate 2x, I'm sure you know you will get 2, and the integral will be cos nx by n cube, and the limits will be 0 to 2 pi. I hope you're okay with this. Look at this, x square becomes 2x and 2x becomes 2. Sine nx will change to minus cos nx by n, and this of course will change to minus sine nx by n square, and integrated gives us plus, will become by n cube. Now what's the next step? Okay, next step is the cleaning process. So I'll erase all these things. No, I didn't mean this sort of cleaning. We are going to throw the unwanted terms outside the bracket. So 1 by pi, and I'll strongly recommend you follow this step. Don't try to save time here. It's better that you write this step. Minus 1 by n x square cos nx within the limits 0 to 2 pi, and plus 2 by n square x sine nx within the limits 0 to 2 pi, and finally 2 by n cube cos nx within the limits 0 to 2 pi. Okay, that's it. Now time to attack. So when we substitute, we will get, I'll put a circle over here and here so that you know the plug-in places. So when you substitute, you're going to get cos 2n pi, which is 1. So you will merely get 4 pi square. And when you plug in the lower limit, you're going to get 0 into something which is finite, and that will be 0. So that's it. Plus 2 by n square. I'll circle the plug-in parts, this one and this one. And you know sine 2n pi is 0, sine 0, 0, 0 into something 0, so that's it. And now the last term, 2 by n cube, and when you plug in this value, you're going to get cos 2n pi, which is 1, cos 0 is 1, so 1 minus 1. Okay, that's it. Goodbye to that term. Now let's erase this. Now we have to simplify. Minus 1 by pi, 1 by n, and 4 pi square, and that gives us minus 4 pi by n. Okay, so note this value, bn equal to minus 4 pi by n. Please put it in a box. Okay, that's it, my friends. It was a little bit lengthy, but I didn't skip any step so that you understand clearly. So now we are going for the last step, and the last step will be substitution. Do you still have equation number 1? Yeah. So we are going to plug in all the values over here. I'll do one thing, I'll erase these things now. So we don't want these quantities. Now we will just focus on equation 1. So look at this. The value of a0 is over here. So a0 by 2 means half of this. So by equation 1, I can write, what is half of this? Yeah, 4 by 3 pi square plus sigma n equal to 1 to infinity. What is an? An is over here. 4 by n square cos nx plus, what's the value of bn? Minus 4 pi by n, and that will be sine nx. Okay, that's it, my friends. We have converted our function into sine and cosines. Anyway, it will be good if you learn to expand and write this in series format. So what we do is, we will start putting values n equal to 1, 2, 3 for the first term. So you can see this 4 is going to be common. So I'm going to get something like 4, and now put n equal to 1, so that you get cos 1x by 1 square plus cos 2x by 2 square plus cos 3x by 3 square plus dot dot dot. And you can see that minus 4 pi is common, so that will be minus 4 pi. Now I'll plug in n equal to 1, 2, 3, etc. So that's going to give me sine 1x by 1 plus sine 2x by 2 plus sine 3x by 3 plus etc. So that's it, that's the last step. So once more I'll explain. The basic aim of Fourier series is to convert functions and put them in terms of sine and cosine. That is, we create a sine and cosine series in such a way that that series will converge into this function. Now if you really want to understand what's happening here, so let's take a look at the video. It goes like this.
I think you can see the parabola forming when we increase the number of terms. And again I am going back and front, and you can see that when the number of terms are very less, it doesn't look like a parabola, but when you keep on adding terms, more and more terms in the series, it becomes a parabola.
So that's it, my friends. We'll stop this video here. I'll be back with more videos, and in the next video we will learn some shortcuts when we have even function and odd function. Anyway, if you like the video, please share, subscribe